So to get started, guys, what are we doing? And just so everybody knows, we are now officially starting our lesson. So let us not continue with any unnecessary chat, please. I'm not trying to be that teacher, but like also I just need to uh be able to monitor the chat. So that's that. Just some revision on what we had done last week. We are doing number patterns. Um, so number patterns, including what happened to Watobi, it was where basically MathsLive got its origin from. It was originally Watobi, and then Watobi closed down. And then the teachers from Watobi formed MathsLive. So we continued on with lessons, just instead of doing it with the company Watobi, we formed our own company and we are now MathsLive. Okay, cool. So we have studied the table below. What we're going to have here is we are having a number pattern. And this is what we know we've been doing, guys. We have been working with number patterns. What did we talk about? We talked about having an input and we talked about having an output. And we said we call our inputs the X values and we call our Y values the output. And then what else did we talk about? We spoke about what we really spoke about was a term number. So our input is our term number and our output is our term value. So if you recall, I used the example of the class list. When they say, okay, number 21 on the class list, does that mean that the child's name is 21? No, 21 is just the number on that list. So the term number, it's not the term itself, it's just the number of the term in the pattern. And then when we look at the term value is like the name on the class list. So let's just say my name is Simone. I'm number 10 on the class list. So that is my term number. But my actual name, the actual value, the term value would be Simone. And so in this case over here, we see we have an input. So my term number is 1. And obviously it makes sense. We number things from 1, 2, 3, 4. So we start at a term number of 1. We get an output of 1. When my term number is 2, I get an output of -2. And so what I want you guys to see is my term numbers, those are just numbers. It just goes 1, 2, 3, 4. So you're never going to find your pattern in your inputs. Whenever they ask you to look for the pattern, you're always looking at your output values. So you're always going to look at your output values. And then, thank you, Emitle. I appreciate that. And Uma, you're saying you think you know the rule. Okay, cool. Don't put it in the chat just yet. Let's talk about it first. So what was I saying? So we're always going to look for our term values. We're going to look at our outputs to determine what is our pattern. And Emitle has raised her hand. Emitle, do you have a question? You're helping me?
I want to help them.
Okay, cool. Tell me what to do.
So, ma'am, to get from 1 to
Mm-hmm.
-3, I
Mm-hmm.
said 1 plus -3, which is equal to -2. And then from -2 to get from -2 to -5,
Mm-hmm.
you add -3.
You add -3, 100%.
And then
So
every
immediately, I just want to stop you there super quickly. I just want to explain to anybody who is like, why are we adding -3? Look at what happens when we add -3. What actually happens is we have this positive and a negative over here. And what do we know? When we have a positive and a negative, it gives us a negative and we're left with 3. So adding -3 is the same thing as subtracting 3. So if you said you were going to subtract 3, 100% the same thing. Okay, sorry, Emihle, carry on.
and then to get from -5 to -8, you add another -3, and yeah.
Okay, cool. Is that what you wanted to help me with? You're answering questions?
No, ma'am, that's over.
Okay, cool. Thank you so much for that, Emihle. I think I saw Itandile had her hand raised. Let me check that. Yes, Itandile.
Hi, ma'am.
Hi, how are you doing?
I'm good, and you, ma'am?
I'm good, thank you. What are you helping me? Asking a question?
I'm helping you, ma'am.
Okay. Are you gonna answer A for me?
Yes, ma'am.
Okay. Describe the pattern for me.
You add -3 to get to the next term.
Okay. So we can add -3 to get to the next term. Can you give me another rule? Another description rather of the pattern?
It's 3x.
No. So I'm
It's
not asking for the algebraic rule. I'm saying describe it in another way. Remember, we said we can add -3 or we can just subtract, right?
subtract -3.
Because, and I see Uma asked in the chat, adding -3 is the same thing as subtracting 3. Do you agree with me, Tandile?
Yes, ma'am, I do.
Okay, cool. Is that the question you wanted to answer, or are you answering that?
I'm answering. Ma'am, can I just ask a question real quick? Ma'am,
Yes.
our teacher, she didn't. We at school we are basically on a not on a new topic, but then we're on the same topic. But then she doesn't use it this way. She has 3x's and stuff.
3 x's.
Like, ma'am, the rule is she gives us the rule and then she says like we need to find y, or sometimes we need to find x.
Okay.
But then the
You'll
rule we
see.
don't. But then the rule we don't describe it in words. She already gave us the rule, and then we just have to figure out y and x.
Okay, so that is 100% correct. And as you say, you moved on to a new topic. So that's the topic we'll be doing next week, and that is functions and relationships. So it's basically number patterns, but taken a step up. So for now, we're still working with how do we deal with these patterns? How do we describe it in words? How do we find a rule? And when we take it that step up, that's when we deal with our functions and relationships, where they give us the rule in an equation form and we have to plot it on the graph. Is that the topic you're doing?
Yes, ma'am.
Okay, so that is a very good question, and you'll see how it all ties in when we start with our functions and relationships topic next week.
Yes, ma'am. Thank you.
Pleasure. I think there's another person who has raised their hand. Nkuli, yes.
Hi, ma'am.
Hi.
Ma'am, I've got a question.
Yes.
So, ma'am, why do we put algebraic equations into the term?
Okay, so when you say algebraic equations, are you talking about this question over here that's asking for an algebraic rule, or are you just talking about the x and the y?
No, like the algebraic rule, because Itandile's question, it confused me, because I don't know where the x and y comes from.
Okay, so all that it is really when we have these number patterns, and you would have seen it easier when we dealt with the flow diagrams. You have an input, and then your input, we apply a rule to the input, and we get an output. And so that's what our inputs and our outputs are. But in maths, I'd like to say that mathematicians were very lazy, and they didn't want to write input, output the whole time. So they just labeled it. Our inputs, we just call it X. And our outputs, we just call them Y. And so when I say Y equals to, all I'm really saying is my output is equals to. I'm asking what is my output? Does that make sense?
Yes, ma'am.
So when I say the output, it would have been, if we had a little flow diagram, we know my inputs here would have been there, and my outputs would have been 1, -2, and -5. I remember seeing you in our flow diagram lesson. So remember we spoke about we had an input, it goes through a machine. This is our rule that we apply in the middle. And once we apply our rule to the input, we get our outputs on the other side.
Yes, ma'am, I remember.
So all that it is we call our inputs X and we call our outputs Y. So when we have an algebraic rule, you'll get something like this. Is just a random rule now. Y is equals to 2x plus 1. You'll get something like this. And why do we want this? I want you to tell me, when I have my input over here, which is X, what do I have to do to it to get my output over here, which is Y? And the way that we do this is we represent it in this algebraic equation. And why do we need it in an algebraic equation? You'll see when we start with functions and relationships, it's just so much easier to work with patterns and to work with these relationships when we have an algebraic rule. So I hope that answers your question.
Does, ma'am.
Okay, cool. Thank you for the question, Kuni. Uma has typed something in the chat that looks very long. X and Y is the same as the blank block. If I'm right. I mean, yes, you are right. And then B, ma'am, I'm right. The pattern, you would subtract 3 from the previous output value of -8, resulting in -11. So the missing value for the input of 10 would be -11. And this is where I want to show you guys how this rule is going to come in handy. So what I want us to do now is let's skip B. Okay, let us skip B because now I know what term 1 is. I know what term 2 is. I know what term 3 and term 4 is. I don't know what term 5, 6, 7, 8, or 9 is. But I have term 10 that I need to put in. And so what are we going to do? We're going to use this pattern. And where do I find my pattern? I find my pattern in the output value. And therefore, I see that you're saying you're confused. Can you tell me what confused you? Where are you confused? Okay, so as we do these examples, you'll see, guys, it's not so bad. So remember, let's leave B out for now. Let's go to C. It says, okay, what I want you guys to really notice is when I do this, okay, this plus -3 is not my algebraic rule. That +3 is what I have to do to get from one term to another term. Now remember, these are just the terms. How do I get from one term to the next term? But what if I told you, what's the value of the 1,000th term? Do I have to now go and write out this pattern 1,000 times to know what is the 1,000th term? Because I have to +3 every single time. So why we have this algebraic rule is it makes it easier for us to find these term values. And so what it does is it gives us a rule where we can now put in our term numbers. So I can put in, okay, my term number is 1,000. What is my output going to be? So that is what the rule is going to help us with. Because remember, if I say term 10 over here, I can't just go +3 and then, or rather plus -3. And then I can't just say, okay, this is -11. It doesn't work like that. And I'll show you why now in a second. To get to term 5, I can say -8 plus -3. That's how that works. So to get to term 10, it would mean I have to plus -3, plus -3, plus -3 until I get to the 10th term, to the 10th number in my pattern. Now, let's see how this rule makes this easier. Remember, we spoke about doing the rule last week. The first thing that we're going to do is we take our input and we multiply it. So we multiply our input with what we add or subtract to get to the next term. Because remember, this rule over here, this plus -3, it's only going to help me find the next term when I have the term before it. Then I know, okay, when I have the term before, I plus 3, I get the next term. But what if I say, okay, now in this pattern, find me the 100th term? Are you guys going to sit and plus 3, plus -3, plus -3, plus -3? No, we can find a rule, and that's going to make it super easy for us to do. So the first thing we're going to do is we multiply our input. And what is my input? My input is x. And we multiply it with what we were plussing or minusing to get to the next term. And we were adding -3. So if you were confused on what I did, I took -3, I multiplied it by x, and that gave me -3x. The second thing I did is I then, well, how can I word this nicely? Oh no. Let's say we then need to add or subtract something to get the output we want. Now, what am I talking about? When I say I want to add or subtract something to get the output we want, so far in my algebraic rule, what I have is, sorry, let me just check the chat. Answer is 30. Close Rorisang. Ma'am, couldn't you multiply 10 by -3, which would equal to -30? No, you could not. -30 is not the answer. Uma says he has the patience to -3 100 times. Bree, no, it is not that. Letty has it, and let's see how we get that. So far what I have is I have negative, and let me go back to my orange. So far what I have is I have -3x. That's what I've gotten so far on my algebraic rule. Can you guys give me a thumbs up or thumbs down? Are you with me here on finding an algebraic rule? Are you happy with applying step 1, where we take our input, which is x, and we multiply it with whatever we were adding or subtracting to get to the next term? Okay, I see some thumbs ups there. So moving on, once we've got that, what we're going to do is we can pick any set of inputs and outputs. So I'm saying when my input is 3, my output needs to be -5. Okay, so if my input is 3, my output needs to be -5. So let's see what we have here so far. I have -3, and if my input is 3, I'm supposed to get -5. But so far with what I have, -3 times 3 is going to give me -9. Okay, that's what I'm getting so far. What is the output we want, guys? When my input is 3, can somebody tell me what is the output that we want it to be? 100%, Uma. We want it to be -5. Itandile, not just 5, -5. So I can see so far what I've gotten is I only have -9. And so what I have to do in the second part is now I have to add or subtract something to get the output we want. So from -9, guys, what do I have to do to get -5? +4. Thank you so much, Tando. 100%. I have to +4. And then all that we have to do after that is write out our equation in an algebraic way. And that is going to say my output is going to be my input multiplied by -3 and then +4. And now, once we've got this rule, we can't just take it as it is. We are doing number patterns right now. So that is the topic that we are on. So we have -3x plus 4. I can't just take my rule and say, yep, I did it 100%. No, I have to check. So let me check. And let's say, okay, let's test it out with this. When my input is 2, I want my output to be -2. So let's check this. I have y is equals to negative 3x plus 4. Now let's see, what does my equation give me when I put in this input of 2? Okay, that is going to give me negative 3 times 2 is negative 6 plus 4. Somebody tell me what is negative 6 plus 4? Negative 2. And can you guys give me a thumbs up or thumbs down now that you see how we went and we used our pattern, we used our inputs, our outputs, and we have now engineered an algebraic expression that works for us. So when I put in my input, it gives me what my output is. We've literally almost created like a machine of our own. I give it something and it gives me something out. Okay, and I see some thumbs up, so I'm super happy with that because everybody was very confused. Okay, so now that we have this algebraic rule, why I wanted us to skip B is let's look at now how easy it makes this question for us. It says fill in the missing values for the input value of 10. Once I have my once I have my equation, all I do is I use my equation, I put the input value into my equation, and I can get my answer. And somebody tell me, what do you get when you put this into in your calculator? When you just multiply out, what do you get? Negative 3. Yes, 100%. Negative 26. Brain break after this? I think so. So we have negative 30 plus 4. So negative 30, where did I get negative 30? Negative 3 times 10 is negative 30. Negative 30 plus 4 is negative 26. Okay, I see everybody seems to be understanding, and that makes me super happy. So before we go into our brain break, this shouldn't take us long now. I want us to do A, B, and C before we get into our brain break. So over here, let's go. I'm just going to do this example. We go from 5 to 3. I can see I am adding. No, I'm lying. I'm not adding 2. I'm minusing 2. And over here, to get from 3, 100% Brie, I'm minusing 2. So if I had to describe the pattern in words, remember this minusing 2 only tells me how to describe it in words. It is not my algebraic rule. Okay, so when I describe the pattern, I minus 2 to get to the next term. I'm not going to write that out. Or instead of minusing 2, you can say you add negative 2. Okay? Minus 2 and adding negative 2 is the exact same thing. So you didn't get anything confused. You just said it in a different way. Rory-san, you don't understand B and C. Okay, we're going to go through it again. And if you're still confused, you can raise your hand and we'll talk about it. So it says now fill in the missing input value of 4. And again, this should be output. Why output? They've already given us our output. They've already given us our input value over here. They want us to fill in this input, the output. And 1 minus 2, somebody tell me, Uma, super fast, negative 1. Okay, so Rory-san, I hope that you understand how we got this negative 1 over here. There was a little bit of a typo. I didn't realize, but we were filling in the missing values for the output because my output for the input of 4 was missing. And how did I get that output? I just went 1 minus 2 gives me minus 1. Then it says, now determine an algebraic rule for the pattern. So let's do step number 1. I'm going to take my input and I'm multiplying it by what we are adding or subtracting to get to the next term. And in this case, I'm multiplying by negative 2. I'm going to multiply by negative 2. Then when we apply step 2, I need to now add or subtract whatever I need to get the output that I want. So if I use this rule so far that I have -2, and then I have the input. Let's use this pair over here. When my input is 1, I know I want my output to be 5. So let's put my input in there. What do I get? I get -2 times 1 is -2. What do I have to do to -2 to get to 5? Uma, be careful. We're going from -2 to +5, guys. Same with you, Tando. It is not 3. No, let's do a number line. Uma, 100% correct. And I don't know why I always attempt to do lines. Oh gosh, freehand. When I've constantly proven that I don't know how to do it. Let's attempt this again. How did we get +7, guys? Think about this. We start over here at -2. Uma, yes. Are you helping me?
Yes, ma'am.
Yes. What do you have to tell me?
So, ma'am, we're not starting off at the number 2. So we add off the 4 numbers before 2. Because -2 to 2, you add 4.
Yes. So
So you
1,
add that for
2,
the
3,
3's.
4. Yes.
So if you add both numbers, you get to 5.
100%. So 100%, Uma, thank you for that explanation. All we did is to get from -2, let's use a number line. All we do is, normally what we'd say is to get from 2 to 5 is 3, but we're at -2 here. So let's go from -2 to +2, that's 4. And now from 2 to 5, we know is 3, and altogether that's going to give us 7 jumps. And so Itandile, you have our rule in there. I'm happy to see that because you were also confused earlier. And so what we have to do is add 7. And so to finish off this, it's going to be -2x. And to get the output I want, I have to add 7. And in my third step, to write it in the algebraic form, my output is equals to -2x plus 7. Everybody happy? Rorisang, I know you specifically said that you were confused. So if you are still confused, please let me know if you still are. Everybody else, give me a thumbs up, thumbs down on where you're at. Yay, I see thumbs ups. I understand now, love that. Okay, guys, now that we've done that, let us go to our brain break. And I did see we had a new, so confused on algebra. Okay, that's okay. We'll look at it another example again, Rory-san, and you're gonna have to tell me exactly where it is that you got lost. So don't ask your question now. Wait until after because it's gonna get lost. But I will, when we start again, I'll remember to ask you what you were confused on. So yes, everybody knows, but for anybody who is new in our class, usually for our brain break, what we do is we play One Must Go. And so we have 4 options. What we do is we pick one that we would get rid of if we had to. One must go. Autumn. Everybody's saying autumn. I kind of like autumn because it's like in between weather, you know. It's not like super hot and it's not super cold. Spring gives me allergies. Summer is hot. Winter is cold. Autumn is nice. Yeah, immediately. Why is no one saying winter? Like, come on, guys. Come on. And our winters don't look like this. We don't get snows. Our winters, you can't even say winter is pretty. Come on, guys. Winter, spring. Wow, everybody's very divided on this. Winter because of hot chocolate. Okay, fair enough. Winter is also my birthday, guys. But I still get rid of winter, you know. We don't have to get rid of our birthdays. We just make the other seasons longer, you know, to like compensate. My birthday is on the 6th of May, English. Uma, yes.
Ma'am, I have to go at spring now. I'm changing my mind.
Why?
See, ma'am, most people get sick during spring. Like around that time, most people get
That's
sick.
true, right? That's what I said. I also get allergies like around springtime. So I totally get your reasoning, Uma. Yeah, I think, yeah, but for me, it would either be spring or winter that I cut. Spring gives me allergies. Same. Same. Next one, guys. Microwave, fridge, oven, stove. Personally, if you're saying anything else other than microwave, I think you're crazy. Yeah, horse?
Ma'am, this is tough, ma'am. Like, this is kind of tough. I don't know. Maybe I'll get rid of stove. I'll
Oh
get rid
my
of stove, yeah.
God.
I think so, ma'am, because the fridge is also important, ma'am. Like, yeah.
The fridge
Even
is
the microwave.
important. But how are you
True.
gonna cook? What meals are you gonna have without a stove?
That's the thing, you see? So it's tough.
The microwave, right? You don't need a microwave. You can just warm your stuff on the stove or in the oven.
True, yeah. Bit of a benefit, yeah.
Yeah, you see. There you go. Yeah.
Yeah. Yeah.
Let's see what Uma has to say.
Ma'am, I'm gonna go with the stove.
Oh my gosh.
Yeah, ma'am. You can use the fire, ma'am. You don't need the stove. You can have a fire. The oven, we need to we need to bake things in the oven.
Okay, fair.
And the stove, we can just light a fire and have a braai or something.
Okay, but why would you go through all that effort of making a fire and stuff when you could just get it out of the microwave and just warm your stuff on the stove, you know?
See, ma'am, when you carry the firewood, you become strong, and also the food tastes better when you cook on fire.
Okay, yeah, I can't deny that. I can't deny that. It's fine. Uma, you win. You win. Let us see what Emile has to say.
Ma'am, I would rather get rid of either the oven or the stove, ma'am, because like with the stove, it like warming food up on a stove would take longer than in a microwave, ma'am.
True, but also we cook like 90% of our meals on a stove, right?
Yes, ma'am.
So Emile, you just don't want to eat. Is that what you're saying?
No, ma'am, I would just rather like in the microwave, like especially if I have to go to hockey or something, and then I just have something to eat on the go, then rather than warming it up on the stove.
Okay, fair enough. You guys are, you guys want the convenience. I get it. Itandile, yes.
Ma'am,
Mm-hmm.
my own opinion, I would take away the microwave.
Thank you. First person to
Away the
agree with
microwave.
me.
The microwave, you don't need a microwave. Like, guys, you have an oven and a stove. You have
Thank
a fridge, for that matter. You take
Thank
away the microwave. The microwave don't matter. If you got the stove and the oven, you got the oven for baking, for frying, for whatever. You got the stove for warming up your food. Although it does take time, but then it doesn't matter, guys.
Yeah. And personally, Itandile, I don't know if you agree with me, but I like it better when food is warmed on
In
the
the
stove than
stove,
in the
then the
microwave.
microwave. The
Yeah.
microwave takes time, and it does all the time. It's busy counting, and you're like, come on, I need my food.
I
I need
love
my
that we are
food.
on the same page. Thank you for agreeing
I just
with
like hate it. Like when it's counting down how many seconds or how many minutes until your food gets ready. I
and
hate
then
that. And
it's
then
busy popping
and
and
then when you give
exploding.
it,
No ways.
no, it's
Popping
better
and
on the
exploding
stove.
only to open it and find that the middle is still cold. No ways, guys. I'd get rid of the microwave. And if anyone says otherwise, I think you're crazy. Thanks, Itandile, for that. Okay, next one, guys. We are on coffee, tea, juice, cold drinks. I heard a hand go up. Uma, I don't know. I think your hand was up now. What is your opinion here?
So my hand was up for the last one, but so I can answer both at once.
Okay.
So ma'am, the one before, if you choose to get rid of the microwave, think about this. You come home from school and you're starving, and you're starving, and now you want food immediately. Now the food is cold, and now you have to go warm it up on the stove again. That's gonna take too much time. And also, the biryani tastes better on fire. And
Okay.
and I'll get rid of cold drinks for this one. Reason being, the other three are more healthier than the cold drinks.
Wow.
Like,
I mean, kudos to you. Kudos to you, because I don't think I could give up cold drinks personally. I
email,
think
you can just put like fizzy water in your juice. You have
I
cold drink.
suppose. It's not the same though, you know, like you won't taste Coke ever again. Coffee. Everybody's saying coffee. The actual drink, not the gossip drink tea. Coffee and tea. So coffee and tea seems to be the consensus here. Honestly, guys, I'd get rid of juice. I feel like that's kind of a controversial opinion looking at the chat because nobody has said juice. But I would do juice. Like, I just don't drink juice that much. Oh, sorry, I didn't see all the hands raised. Liaho, Itanila, I don't know if your hand was still up from
Ma'am, tea
before.
has to go, ma'am. Definitely, ma'am. Ma'am, I never drink tea. I usually drink coffee, but I don't really drink coffee that much. But I like Coke, I like juice. Mostly orange juice. I like orange juice. But ma'am, tea has to go, definitely. Do you agree
Okay.
or
I don't know. I don't know if I agree. Because you see, it depends on the tea. Like, what tea do you drink? What tea do you have at your house, Liaho?
ma'am, Raybos?
Okay, yeah, Sam, I love rooibos.
Okay, cool,
Like, you
ma'am.
know, when you're sick and you just have a cup of rooibos, like, this makes everything better. So, I don't know.
Yeah.
And like
Usually
also
when I'm
butter
sick.
bread and tea. I don't know if do you guys eat butter bread and tea? Like, is that a thing?
No, ma'am, no, ma'am.
No.
No,
Guys,
ma'am.
please try it, Liaho, and then come back to me and tell me if you change your mind on the tea, okay?
Okay, ma'am. Okay, ma'am. I'll do that.
Okay.
No problem.
Okay. Okay, thanks, Liaho. Uh, guys, I want to give somebody a chance to speak who has not spoken as yet. So I'm gonna ask Leila.
Hello, ma'am.
Hi, how are you?
I'm good, ma'am.
Good. What is your take?
Ma'am, I'm sorry.
What's your take?
I would say coffee because coffee is just there. Coffee is just there to give you energy. Plus, it tastes bad. Plus, we have a better one that still gives you energy. That still gives you energy and tastes better. For example, cold drinks. We have like energy drinks. I think that falls under that section.
That's fair. That's fair. I also don't think coffee tastes like the greatest, but I'm just so used to it now that I don't know if I could get rid of it, you know?
Yeah, ma'am. But the coffee, they taste bad.
I get that. I agree. I do agree. Especially when you buy it out, they make it so strong. It's just like butter. I get it.
Yeah, ma'am.
Thank you for sharing that with us. Guys, you can keep your hands up. I'm gonna go to the next one. So I will ask you, but we're answering the next one now. So I'm gonna take 3 hands, and I'm sorry, but I'm skipping people who have answered before. Zach, I didn't hear you today.
Hi, ma'am.
Hi, Zach.
Can I sorry, give an answer for the last one?
Okay, sure.
Okay, I just think tea and coffee sometimes can taste very different. Depends at like what restaurant you are at.
Yes.
Sometimes coffee can taste horrible and
Mhm.
tea can taste better, but sometimes coffee can taste better and tea can taste horrible. Really depends on the place you're in. But
That's
get
true.
rid of juice because you don't need to drink orange juice. You can just drink Fanta. Let's
Thank
be
you.
honest.
Thank you, Zach. You're on the same page as me. Love that.
Thank you, ma'am.
Okay, what is everybody saying? Phineas and Ferb barely even plays anymore. People are getting rid of Phineas and Ferb. Valentine, I'm with you. Adventure Time can go. Adventure Time can like exit the chat. It can leave. I'm sorry. Let's see. Is there a hand I haven't heard? I don't think I heard you today, Bree.
Hi,
Hi, ma'am. I'm
everyone.
saying hi, ma'am. Oh my gosh. Hi, Bree.
Personally, I'll get rid of Phineas and Ferb because I've always heard about people watching it, but I've never watched it. And like personally, I can't get rid of Teen Titans and SpongeBob SquarePants. Those are my go-to cartoons. The rest can go.
Okay, fair enough. But try watching Phineas and Ferb. Adventure Time, I agree that it can go. But try Phineas and Ferb. It's really good. Especially the song. Do you at least know the song, Bree?
No, okay, I've watched snippets and like for 5 minutes, and then I got bored. So
Oh, come on, guys. The song. There's 104 days of summer vacation. Does nobody know the song?
oh, that
That
one. Oh,
one.
okay, yeah, I do know it.
Yeah,
Yeah.
there we go. Okay, Bree. Yeah, I get it. Let's see what somebody else has to say. I'm gonna take the last hand. Emilia, I don't think you shared anything today with us on this brain break.
So, ma'am,
Mm-hmm.
I would not take away Teen Titans, SpongeBob SquarePants. Actually, I wouldn't take away any of these because, like, I grew up watching them a lot. But Phineas and Ferb, it like you know how in the beginning of the theme song it's like there's 104 days of summer
Mm-hmm.
vacation. So now, man, like when in every single um episode that of every season that I've watched, they've always Phineas and Ferb have always been at home. Like they haven't gone to school at all. So I find it really weird.
I mean, I get that, but the whole thing is that there's 104 days of summer vacation, so they are there at home for a lot. What's good? It's good. Kathy. What is Kathy? No. The Adventures, the comedy, the inventions, the fights, the many songs. Oh, you're talking about Phineas and Ferb. Phineas. Yeah, also. Uma, you hate SpongeBob. I don't know what to say to you. I don't know what to say to you. But anyways, that is that, guys. I hope that we are ready to go. Rory-san, I still remember. Is there something specifically that is confusing you? I can even go back up. Let's go back up super quickly. And I'm going to lower all the hands quickly. Rory-san, the X and the Y. Okay. So I'm not sure exactly what about the X and the Y you're saying that is confusing you, but if you were here, and I think you were, what I said is that all that happens with the X and the Y is instead of saying the input is 1, we just rename the input as X. So it's a variable because remember, my input can be anything. And so I use a variable to represent my input so that I can put in any input I want in. So when I have an input that I want to put into my equation, I can just substitute it in for the variable. And you'll see that's exactly what we did over here. We had 3x plus 4, and my x was my input. Remember, we just call our x's the inputs. We call the inputs rather the x. And so here, when they asked us, fill in the missing values for an input of 10, all I did is I replaced x, which is my input, with the actual value of my input of 10. And then I could use that to calculate what y was. And y is what? Y is my output. And that gave me negative 26 over there. So I hope that makes sense and that you're a little bit more comfortable with that. Okay, I'm still seeing a lot of brain break talk going on. So, Rorisang, I don't know if you said anything, but you can just give me a thumbs up if you're getting it now. If not, raise your hand, please. Let's talk about it. While we wait for Rorisang, what I am going to do is I'm going to show you guys a little bit of a step up. What we were doing is we were speaking about our inputs as X. Yes, here we go. Yes, Rory-san.
Ma'am, now I understand, ma'am. Thank you.
Okay. And so keep in mind what I just said, because now we have new names for our inputs and outputs. So we have N and TN, and I'm going to explain it now. And I hope that it makes sense. But guys, like I said, ask questions if you still don't get it. So yeah. So now what we've been dealing with so far is we've been calling our inputs and our outputs X and Y. Now, when we deal with number patterns specifically, okay, we have a certain notation that we use. Okay, and what do I mean when I say notation? It's just almost like the presentation of it. It's the name. We have a certain name that we call things. And we have N over here and Tn. And so my N is basically what my X values were. And what is that? It's my input. And what do we know my inputs are? My inputs are my term numbers. Okay. And then we have Tn. So what was Tn? We know Tn as Y. Okay. So my Y values, instead of calling them Y now, what we do is we call them Tn. And we know that Y is my outputs. And what do my outputs represent? My outputs represent my term values. So instead of having an equation that's now going to look like this, we have a new equation using my Tn notation that's going to say Tn is equals to 2n plus 1. And how did I get that? All I did was I said, okay, my x is now n. So where my x was here, I replaced it with n. And then Tn is y. And so where my y was here, I replaced it with Tn. Okay, guys, let's please stop talking about our brain break. Because let me just scroll quickly and look for questions. I'll ask for suggestions for our next brain break after the class, since I see you guys are doing that. But for now, can you guys give me a thumbs up and thumbs down to tell me, are you okay with this TN notation? Do you understand that it's just a renaming of our inputs and our outputs? Bree, you're giving me thumbs ups. Umar, Shady. Now let's focus on master maths. Thank you, Layla. That it'll all make sense now in a minute. And so let us look at this. They are saying, consider the pattern 7, 10, 13, 16. What I want you guys to see is I could have numbered this as term 1, term 2, term 3, term 4. And so all that we did here is we put this into a table. Look at it. 1, 2, 3, 4, 7, 10, 13, 16. 1, 2, 3, 4, 7, 10, 13, 16. So that, by the way, guys, is how we take a number pattern and put it into a table format. And now they are asking me, what is the value of the 25th term in the pattern? To do that, I'm not going to go and fill in plus, 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 plus to get to 25. To do that, I'm going to find an algebraic rule, and then I can find the value of the 25th term. So let's do that. To get from 7 to 10, I have to plus 3. To get from 10 to 13, I have to plus 3. And so plus 3. And so we can fill in 5, 6, and 7, okay? 16 plus 3 will be 19. 19 plus 3 will give me 22. And 22 plus 3 will give me 25. Did I just say plus 2? I meant plus 3. Now, why was that easy? Because my term numbers were just going in once. You know, we were just going from one term to the next. And that's what this +3 gives me. It tells me how to go from one term to the next term. But now to get my 25th term, can I go from the 7th term to the 25th term? No, that's not going from one term to the next term. That is jumping a whole lot of term numbers. So what I want to do is I want to find an algebraic rule. And let's do that super quickly. The first thing I'm going to do is I'm going to take x, which is my input, and multiply it by 3. And that's going to give me 3x. The second thing I'm going to do is I'm going to say, okay, when I have 3x, x is what? X is my inputs over here, which would be this. And let's go n and tn, or x and y, just for us to know. N is the same thing as x. Tn is the same thing as y. And so I'm going to take my input. So let's say when my input is 2, I want my output to be 10. And so let's put in my input. If I have 3x, that's just going to give me 6. But what do I want my output to be? I want my output to be 10. And so what I'm going to do is I'm going to add 4. So this now goes from 3x to 3x plus 4. Itandile, you have the rule 100%. And let's do step number 3, but let's not write it in x and y notation. Let's do it in tn notation. And that is going to tell me that tn is equals to 3n plus 4. I hope that made sense to everybody. And so now that I have that, and I'm going to say n is going, let's go, tn is equals to 3n plus 4 over there. 100% Itandile. Uma, you're saying yes, that's great. Now let us see what is the 25th term in the pattern. What I want you guys to tell me, should I put in 25 where I have tn, or should I put in 25 where I have n? Is 25 my input or my output? I see you guys saying in. 100%. 25 is my term number, and my term number is my input. So what I'm going to do is instead of saying n, I'm going to put in 25. And if somebody has the answer over here, that would be great. I'm seeing 3 times 25 is 75. And 75 plus 4 is going to give us 79. Uma, 100%. Itandile, thank you. Okay. That is going to bring us to the end of our lesson for today. What I want you guys to do is please go back. I hope you've taken screenshots. Go back, revise, try and do it for yourself. And as always, if you have questions, please stay behind and ask them. And I see Refilwe has raised their hand. Yes, Refilwe. While we wait for Refilwe, I think I have the quiz podium. So well done to Scarlett, Layla, and Liaho. You guys did super well on the quiz from last week. So that was super cool. Ma'am, question, do we ever do scientific notation? Not in number patterns, no. You will use scientific notation in your maths career, but not when you're dealing with this topic specifically. Okay, Refilwe, I'm not getting any question from you, so I'm going to take Itandile. So long. Bye, everybody, to everybody who's leaving. Yes, Itandile.
I'm asking a question, ma'am. When you are figuring out the algebraic term, ma'am, is it a must to show that x is times 3?
No. So you're saying you want to skip this step over here. You don't want to show this part.
Bye, ma'am.
Yes, ma'am.
Bye. Yeah, no, you don't have to do this. I was just doing it to expand it and, obviously show you guys how I got 3x.
Yes, ma'am. Ma'am, can you please send the worksheets that we're doing on Google Classroom?
Okay. I'll send these questions that we haven't done. I'll put it onto a worksheet and send it to you guys in Google Classroom.
Thank you, ma'am.
Pleasure.
Bye.
Bye, Tandile. Refilway, do you have I see you unmuted. Do you have a question?
Bye.
Bye.
ma'am.
Okay, Rory-san, yes, let's take your question.
Bye. Ma'am,
Bye.
on the now like number 2, like the first example you gave us, you got 3x plus 4. So I'm wondering, how did you get that 4?
Okay, so look at what we did, Rory-san. Remember my first step was to multiply what I was adding and subtracting here. I was multiplying that with my input. Are you with me there so far on how I got 3x?
Yes, ma'am.
Okay, then what I did is, remember what my second step is, and let's go to where I wrote it. The second thing is we're going to add or subtract something to get the output that we want. So based on what I have over here, I only have 3x, right? And so if I look at this table over here, when I have
Yes,
an
ma'am.
input of 2, when my input is 2, Rory-san, what do I want my output to be? Rory-san?
That's where I'm confused.
Okay, so look at what the table does, right? The table gives me my position of the term and it gives you the value of the term. What you should know is that the position of the term is my input. You with me there?
Yes.
So what am I saying? I'm saying all of these are my inputs. All of these numbers on the top, the positions, those are my input values. You with me?
Yes, ma'am.
Okay. And then we have the value of the term. The value of my term is my output. So remember, we're dealing with number patterns. So my output is what creates the pattern. So the output is really where I'm going to find my number pattern. And those are what we call my outputs. You with me there?
Yes, ma'am.
And so how it actually works is, if you look at what we had here initially we had this number pattern of 7, 10, 13, and 16. And what I did is I went and I numbered this. So I said, this is number 1, this is number 2, this one is number 3, and this is number 4. Are you seeing that?
Yes, ma'am.
So these were my term numbers, and the bottom part is my term values. And all that we did is we put that into a table. We tabulated. And can you see 1 and 7 gives us that? 2 and 10 gives us that. You seeing that?
So, ma'am, if it ended not at 4, maybe at 3, at 13, would it also be like plus 3?
To get to 4, yes. To get to term number 4, we would plus 3.
Oh, so if it ended also at 5, then you're also going to say plus 5.
No. Okay, I see what you're saying. Look at how this number pattern is working. To get from 7, and let me erase everything over here. Let's look at this. And I just want to stop the recording super quickly. I still see there are 5 people. You guys are more than welcome to leave. Obviously, except you, Rory-san.